madly Mesozoic, YouTuber, evolutionist, paleontologist, zoologist, survivalist, and creator of Samsung.
Today, I challenge madly Mesozoic giant hybrid elephants with a super hybrid predator. In recap of creating a behemoth to vanquish the Indominus 2.0, he didn't create a super carnivore against a super carnivore, but super herbivore against a super carnivore. And he didn't use dinosaur DNA against a dinosaur hybrid, but used mammalian DNA against a dinosaur hybrid. Paleoloxodon for the base genome, the blue whale for their size, Glyptodon for their armor, Megatherium for their powerful limbs and heel bone front and back, the bighorn sheep for their curved horns, fruit bat for their immune system, scaly-foot gastropod for their iron-infused armor. The question is, what animal do I want to create?
Part 1.
The African lion, Panthera leo, is one of the most iconic apex predators on Earth. Known for their muscular build, social pride structure, and thunderous roar, lions dominate the savanna. Males can weigh over 190 kilograms, while females, smaller but faster, are the primary hunters. Their cooperative hunting style allows them to take down prey far larger than themselves. Lions possess powerful forelimbs, retractable claws, and a bite force capable of crushing bone. Their keen eyesight, especially at night, and acute hearing make them formidable stalkers. In the wild, they are symbols of strength, strategy, and raw predatory instinct. While most predators avoid elephants, certain prides, like the legendary Savuti lions of Botswana's Chobe National Park, have mastered the art of hunting them. These lions target juvenile or sub-adult elephants, often during the dry season when herds gather at shrinking waterholes. Working in coordinated waves, they exhaust their prey, attacking from multiple angles to avoid tusks and trampling feet. Night hunts give them the advantage, as elephants' vision is weaker in low light. By isolating individuals from the herd, the lions exploit moments of vulnerability. This rare but deadly tactic proves their adaptability and fearlessness in the face of giants. The African lion earns its place as the base genome for our super hybrid predator because it brings the perfect blend of strength, coordination, and psychological dominance. Its social intelligence translates into battlefield tactics, while its muscular frame and predatory reflexes form the foundation for lethal efficiency. Lions already possess the courage to challenge the largest land mammals alive, making them a natural starting point for a creature designed to face Samson, the giant hybrid elephant. By building on the lion's proven ability to strategize, endure, and overpower massive prey, we ensure our hybrid begins with a predator's heart and a warrior's mind. Part 2. Smilodon. The Smilodon, often called the saber-toothed cat, was one of the most formidable predators of the Ice Age. Standing over a meter at the shoulder and weighing up to 400 kilograms, it had a stocky, muscular build, short tail, and incredibly powerful forelimbs. Unlike modern big cats, Smilodon relied less on speed and more on ambush tactics, using its strength to wrestle massive prey to the ground. Its iconic saber teeth, up to 28 centimeters long, were precision weapons for delivering fatal bites to the throat or soft tissue. Fossil evidence suggests it hunted in groups, targeting megafauna others dared not approach. Paleoloxodon, the largest elephant species ever, was vulnerable only to coordinated, high-risk attacks. Smilodon's strategy: isolate the young, sick, or injured, then use its muscular forelimbs to topple them. Once grounded, the saber teeth could pierce the neck or windpipe, ending the fight before the herd could intervene. Glyptodons were armored like tanks, but Smilodon exploited their slow turning speed. By targeting the unarmored underside during a roll or stumble, it could deliver a killing bite. Patience and precision were key, waiting for the moment the Glyptodon exposed its vulnerable belly or neck gap in its shell. Megatherium, the giant ground sloth, was a towering herbivore with deadly claws. Smilodon's success came from ambushing at close range, leaping onto the back, and using its weight to destabilize the sloth. A swift, deep bite to the throat or neck arteries could end the battle before Megatherium's claws struck. We integrate Smilodon's saber teeth into our super hybrid predator for one reason: armor penetration. Against Samson's thick hide and Glyptodon-style plating, these elongated canines can slip between armor gaps to sever arteries or crush windpipes. They're not just weapons, they're surgical tools for bringing down giants in hybrid war. Part 3. Orca, the killer whale. Orcinus orca, often called the killer whale, are the ocean's ultimate apex predator. Belonging to the dolphin family, these highly intelligent mammals are found in every ocean, from polar seas to tropical waters. Adult males can reach 9 meters or 30 feet and weigh up to 6 tons, while females are slightly smaller but equally formidable. Orcas live in tight-knit pods led by matriarchs, passing down complex hunting strategies through generations. Their diet is incredibly diverse, from fish and seals to sharks and even large whales. With speed, power, and unmatched cooperation, orcas dominate the marine food chain. Recent documented events off Australia have confirmed what was once only suspected. Orcas can and do hunt the largest animal on Earth, the blue whale. Pods of 50 to 75 individuals work together, targeting the whale's blowhole to suffocate it, raking its flanks with teeth, and even tearing at its tongue mid-hunt. These attacks rely on relentless pursuit, coordinated strikes, and exploiting the whale's need to surface for air. By overwhelming their prey with sheer numbers and precision tactics, orcas achieve what no other predator can, bringing down a creature over twice their length and more than 20 times their mass. Orca's large size, up to 6 tons, gives them the strength to ram prey, resist injury, and endure long hunts. Their muscular bodies store immense power for bursts of speed, while thick blubber insulates them in frigid waters, allowing them to operate in extreme marine environments year-round. Orcas use echolocation, like a biological sonar, emitting clicks and listening for echoes to map their surroundings. This allows them to detect prey hidden in darkness or murky water, coordinate attacks without visual cues, and even identify the size, shape, and movement of targets from remarkable distances. Integrating orca DNA gives our super hybrid predator unmatched cooperative intelligence, aquatic adaptability, and sensory precision. In hybrid war, this means the ability to strategize like a pod, strike with overwhelming force, and track Samson across any terrain, even if the battlefield shifts from land to water. Part 4. Cougar. Cougar, Puma concolor, also known as the mountain lion or puma, is one of the most adaptable big cats in the world. Found from Canada to South America, it thrives in forests, deserts, and mountainous terrain.
Adult males can weigh up to 100 kilograms with powerful hind legs capable of leaping over 12 meters in a single bound. Cougars are solitary, stealthy hunters, relying on acute vision and hearing to stalk prey. Their muscular build, retractable claws, and crushing bite force make them lethal ambush predators. Despite their size, they are remarkably agile, able to navigate cliffs and rocky slopes with ease.
Bighorn sheep inhabit rugged, high-altitude terrain where few predators can follow, but cougars are the exception. Using stealth and patience, a cougar will shadow a herd from the shadows of cliffs or ridges, waiting for the perfect moment. Their powerful hind legs allow them to leap across gaps and scale near vertical rock faces, matching the sheep's agility. The attack is sudden, a high-speed pounce from above or behind, targeting the neck to sever the spinal cord or crush the windpipe. This combination of stealth, explosive power, and mastery of dangerous terrain makes the cougar the sheep's most formidable natural enemy. Cougar DNA brings our super hybrid predator unmatched agility, stealth, and vertical combat ability, traits essential for challenging Samson, the giant hybrid elephant. While Samson's size and armor make him a fortress on four legs, the cougar's genetic legacy equips our predator to exploit elevation, leap onto vulnerable areas, and strike with precision. The cougar's ability to stalk undetected in complex terrain mirrors the tactical patience needed to wear down a massive opponent. By integrating these traits, our hybrid gains the capacity to outmaneuver, outflank, and deliver lethal blows from unexpected angles, turning the battlefield's geography into a deadly advantage. Part 5. Short-tailed shrew. The northern short-tailed shrew, or Blarina brevicauda, is a small but extraordinary mammal, measuring only 3 to 4 inches long and weighing less than an ounce. Despite its size, it's one of the few venomous mammals on Earth. Living mostly underground, it hunts insects, worms, amphibians, and even small mammals, using a combination of stealth, speed, and toxic saliva. Its metabolism is incredibly high, forcing it to eat nearly its body weight in food each day. With poor eyesight, it relies on touch, smell, and echolocation-like clicks to navigate. This tiny predator is a master of lethality in miniature, a perfect example of small size hiding immense danger. Short-tailed shrews have a unique adaptation. Their teeth are infused with iron, giving them a dark reddish tint. This iron-rich enamel is concentrated on the high-stress cutting and crushing surfaces, making the teeth far more resistant to wear than ordinary mammalian teeth. The contrast between the harder iron-pigmented enamel and the softer white enamel also helps keep the cutting edges sharp over time, as the softer areas wear down faster. This adaptation is crucial for an animal born with its permanent teeth, ensuring they remain effective throughout its short but intense life, a natural upgrade for durability and precision. Incorporating short-tailed shrew DNA into our super hybrid predator grants it 2 lethal advantages: biochemical warfare and armor-piercing dentition. The venomous saliva could weaken or paralyze even large opponents over time, bypassing brute force with biological sabotage. Meanwhile, the iron-infused teeth ensure that every bite remains razor-sharp and capable of penetrating tough hides or armor-like plating. Even Samson's Glyptodon-inspired defenses. This combination of chemical and mechanical weaponry transforms our hybrid's bite into a multi-layered attack. Immediate trauma, sustained bleeding, and systemic debilitation. In hybrid war, that means our predator doesn't just wound, it cripples, ensuring the giant falls.
Part 6. Vampire Bat. The common vampire bat, or Desmodus rotundus, is a small, nocturnal mammal native to Central and South America, famous for its unique diet, blood. Unlike most bats, it walks, runs, and even leaps on the ground using its strong forelimbs. Vampire bats locate prey using heat sensors on their noses, then make a small incision with razor-sharp teeth. They lap rather than suck the blood, feeding for up to 30 minutes. Their social intelligence is remarkable. They share food with roostmates that failed to feed, strengthening colony bonds. This combination of stealth, precision, and cooperation makes them highly specialized predators.
Vampire bat saliva contains a powerful anticoagulant glycoprotein called draculin. This compound inhibits clotting factors 9A and 10A in the blood coagulation cascade, preventing the victim's blood from clotting while the bat feeds. Draculin acts immediately upon contact, keeping blood flowing freely for extended periods. In addition, their saliva contains vasodilators, such as a bat-specific form of calcitonin gene-related peptide, VCGRP, which widens blood vessels to increase flow. This biochemical arsenal ensures a continuous meal and has even inspired medical research into stroke treatments, as its clot-dissolving properties could help restore blood flow in human patients.
Blood is rich in iron, and vampire bats consume large quantities of it every night. To handle this, they have evolved specialized digestive and metabolic systems. Their stomach rapidly separates plasma from red blood cells, absorbing nutrients while passing excess water quickly to reduce weight for flight. The iron from hemoglobin is processed efficiently, with specialized transport proteins moving it safely through the bloodstream. Gut microbes also play a role, helping break down and recycle iron without causing toxicity. This adaptation allows vampire bats to thrive on a diet that would overwhelm most mammals with iron overload. Vampire bats have evolved genetic and physiological defenses against iron toxicity. They produce high levels of ferritin, a protein that binds and stores iron safely, preventing it from generating harmful free radicals. Their livers are adapted to process and excrete excess iron efficiently, and their kidneys filter waste products without damage. Additionally, their gut lining limits uncontrolled iron absorption, balancing intake with the body's needs. These mechanisms allow vampire bats to consume iron-rich blood nightly without suffering from hemochromatosis or oxidative stress, a feat that would be lethal to most other mammals. Combining the vampire bat's iron absorption and overload resistance genes with the short-tailed shrew's iron-infused teeth would create a predator with both biochemical resilience and permanent armor-piercing dentition, a mouth built to bite through the toughest defenses and metabolically thrive on the blood of even the largest prey. Adds a biological sabotage system to our super hybrid predator. The anticoagulant venom ensures that any wound inflicted bleeds continuously, weakening even massive opponents like Samson over time. The bat's iron-handling adaptations allow the predator to feed on blood-rich tissue without risk, turning Samson's size into a liability. Combined with stealth, heat detection, and precision biting, these traits make our hybrid a relentless finisher, capable of inflicting damage that worsens with every passing second. In hybrid war, this means our predator doesn't just overpower its target, it drains its strength until the giant can no longer stand.
Part 7. African Wild Dogs. Lycaon pictus, also known as the painted wolf, is one of Africa's most efficient and endangered predators. Recognizable by their mottled coats and large rounded ears, these canids are built for endurance and teamwork. Adults weigh between 18 to 36 kilograms, but can run at speeds of 60 kilometers per hour for extended periods. They live in tightly bonded packs, where cooperation is the key to survival. Unlike solitary hunters, wild dogs rely on group strategy to take down prey much larger than themselves. Their success rate in hunts is among the highest of any predator, often exceeding 70% in the wild.
African wild dogs excel at coordinated hunting. Before a chase, the pack silently positions itself to intercept prey, often using terrain to their advantage. Once the hunt begins, individuals take turns leading the pursuit, allowing others to rest mid-chase. This relay-style running exhausts prey over long distances. When the target slows, the pack closes in from multiple angles, overwhelming it with speed and precision bites to immobilize vital areas. The kill is swift, minimizing injury risk to the hunters. Feeding is equally organized. Pups and weaker members eat first, ensuring the survival of the entire pack, rather than just the strongest.
African wild dogs have one of the most complex social systems in the animal kingdom. Packs are led by a dominant breeding pair, the alpha male and alpha female, but decisions are often made collectively. All adults help raise the pups, regurgitating food for them and guarding them while others hunt. Hierarchy is maintained through subtle behaviors rather than constant aggression, creating a stable and cooperative environment. This communal approach ensures that every member, from the strongest hunter to the youngest pup, plays a role in the pack's survival. Such unity is rare among carnivores and is key to their success. Communication is the lifeblood of an African wild dog pack. They use a rich combination of vocalizations, high-pitched twittering, yips, and rally calls to coordinate hunts and maintain cohesion over vast distances. Body language, such as tail positions and ear movements, conveys mood and intent instantly. Scent marking reinforces territory boundaries and helps track pack members. Before hunts, a greeting ceremony of excited calls and physical contact boosts morale and synchronizes the group's readiness. This intricate communication system allows them to adapt mid-hunt, respond to threats, and operate as a single, highly efficient unit in the chaos of the chase. Integrating African wild dog DNA into our super hybrid predator infuses it with pack-level tactical intelligence and relentless endurance hunting. Even if our hybrid operates alone, these instincts translate into advanced pursuit strategies, efficient energy use, and the ability to anticipate prey movements. In a confrontation with Samson, this means our predator won't rely solely on brute force. It will wear the giant down, exploit openings, and strike with precision. The wild dog's cooperative mindset also enhances multi-target awareness, allowing the hybrid to manage complex battlefields. In hybrid war, this DNA ensures our predator fights not just as a beast, but as a strategist. Part 8. Sahelanthropus chidensis, nicknamed Tumai, is one of the oldest known species in the human family tree, living between 7 and 6 million years ago in what is now Chad, Central Africa. Standing about 1.2 meters tall, it had a small brain, smaller than a chimpanzee's, a sloping face, and prominent brow ridges, but also human-like traits such as small canine teeth and a forward-positioned foramen magnum, suggesting upright walking. This early hominin thrived in mixed habitats of forest and grassland, likely feeding on fruits, leaves, seeds, and insects. It represents a critical stage just after the human lineage split from chimpanzees.
Human evolution is the long biological process by which modern humans, Homo sapiens, emerged from earlier hominin species. The journey began in Africa roughly 6 to 7 million years ago, when our lineage diverged from that of chimpanzees. Early hominins, like Sahelanthropus chidensis, marked the first steps toward bipedalism, walking upright on 2 legs, which freed the hands for carrying food, infants, and eventually tools. Over millions of years, species such as Australopithecus afarensis, Lucy, refined upright walking and developed more dexterous hands. Around 2.5 million years ago, Homo habilis appeared, showing the first clear evidence of stone tool use. This technological leap allowed early humans to process meat, shape wood, and defend themselves more effectively. Later species, including Homo erectus, mastered fire, expanded out of Africa, and developed more complex social structures. Eventually, Homo sapiens emerged about 300,000 years ago with advanced language, symbolic thought, and culture. The evolutionary path was not linear. Many hominin species coexisted, competed, and sometimes interbred. Studying early ancestors like Sahelanthropus helps scientists understand the anatomical and behavioral foundations that shaped our survival even before the invention of tools.
Integrating Sahelanthropus chidensis DNA into our superhybrid predator adds primal human adaptability without the reliance on tools. This species' upright posture offers a combat advantage, freeing forelimbs for grappling, striking, or climbing while retaining raw, instinct-driven survival skills. Unlike later humans, Sahelanthropus relied solely on physical ability, environmental awareness, and social interaction to survive. In hybrid war, these traits translate into a predator that can navigate diverse terrain, assess threats quickly, and engage with both brute force and strategic positioning. It's the perfect blend of early human resilience and animalistic ferocity, a thinking hunter without technological crutches.
Part 9. The koala, Phascolarctos cinereus, is an arboreal marsupial native to Australia, spending nearly its entire life in eucalyptus trees. Despite their teddy bear-like appearance, koalas are highly specialized climbers with strong muscular limbs and a lean body built for balance. They feed almost exclusively on eucalyptus leaves, which are low in nutrients and toxic to most animals, relying on a slow metabolism to conserve energy. Koalas are solitary, territorial, and mostly nocturnal, resting up to 20 hours a day. Their evolutionary adaptations for life in the treetops make them one of the most skilled climbers in the animal kingdom. Koalas possess remarkable climbing adaptations. Each front paw has 5 digits, 2 opposable thumbs, and 3 fingers, all tipped with long, sharp, curved claws for gripping bark. Their hind paws also have 5 digits, with 1 large opposable toe without a claw for grasping, and a fused second and third toe forming a grooming claw. Rough pads on their palms and soles enhance grip, while powerful forearm and thigh muscles allow them to cling vertically to tree trunks for hours. This unique combination of opposable digits, hooked claws, and muscular strength gives koalas unmatched climbing precision and stability. Integrating koala DNA into our super hybrid predator grants it arboreal mastery and grappling versatility. The koala's dual opposable digits and razor-sharp claws would allow the hybrid to scale vertical surfaces, cling to massive opponents like Samson, and maintain a secure hold during combat. In hybrid war, this means our predator could launch ambushes from above, cling to Samson's armored flanks, or reposition rapidly in complex terrain. The enhanced grip strength and climbing endurance from koala genetics would turn vertical environments into tactical strongholds, giving our predator a three-dimensional battlefield advantage that Samson's sheer size and ground-based power cannot easily counter.
Part 10. The Sloth. Sloths are slow-moving, tree-dwelling mammals native to Central and South America, divided into two main groups, two-toed and three-toed species. They spend nearly their entire lives in the rainforest canopy, hanging upside down from branches, feeding on leaves, buds, and fruit. Their low-calorie diet drives their famously slow metabolism, which in turn shapes their deliberate movements. Sloths are surprisingly strong for their size, with powerful limb muscles adapted for suspension rather than speed. Their shaggy fur often hosts algae and insects, providing camouflage. Despite their gentle appearance, sloths are highly specialized survivors, perfectly adapted to life high above the forest floor.
A sloth's most distinctive feature is its long, curved claws, extensions of elongated distal phalange bones covered in keratin. These claws act like natural hooks, allowing sloths to grip branches securely without expending much energy. Specialized tendons in their hands and feet lock the claws in place passively, enabling them to hang for hours, even while sleeping. This adaptation is crucial for conserving energy and avoiding predators, as sloths rarely descend to the ground. Their claws also serve as formidable defensive tools, capable of delivering deep slashing wounds if threatened. In the canopy, these claws are both lifeline and weapon.
Incorporating sloth DNA into our super hybrid predator adds grappling endurance and energy-efficient suspension. The sloth's curved claws and tendon-locking mechanism would allow the hybrid to cling to Samson's massive frame or armored flanks without tiring, maintaining a secure hold during prolonged combat. This creates opportunities for sustained attacks, venom delivery, or targeted strikes to weak points. The claw's dual role as climbing tools and slashing weapons enhances the hybrid's versatility in both arboreal and ground-based encounters. In hybrid war, this means our predator can turn Samson's size against him, latching on like a living vice until the giant falls.
Part 11. Giant Armadillo. Priodens maximus is the largest living armadillo species native to South America's grasslands, forests, and savannas. Adults typically measure 75 to 100 centimeters, 30 to 39 in body length, with the tail adding another 50 centimeters or 20 in, and can weigh between 18 to 32 kilograms, though some individuals reach up to 54 kilograms in the wild. Their most striking feature is their enormous foreclaws, especially the sickle-shaped third claw, which can grow up to 22 centimeters or 8.7 in, proportionally the largest claw-to-body ratio of any living mammal. These claws are powerful digging tools used to tear open termite mounds, excavate burrows, and even break into beehives.
The giant armadillo's body is protected by 11 to 13 hinged bands of bony armor, with additional plates on the neck and head. They are nocturnal, solitary, and elusive, spending much of their time underground. Their diet consists mainly of termites and ants, but they also consume worms, larvae, spiders, snakes, and plant matter. Despite their size and formidable claws, giant armadillos are not aggressive toward humans, but they can defend themselves effectively if threatened. Sadly, they are considered vulnerable due to habitat loss and hunting, making them a rare and fascinating survivor of the Xenothrin lineage.
Incorporating giant armadillo DNA into our super hybrid predator adds a devastating armor-piercing and disabling capability. Samson, the giant hybrid elephant, is protected by thick hide and Glyptodon-inspired plating. But the giant armadillo's massive, sickle-shaped claws are designed to breach hardened defenses. In hybrid war, these claws could hook under armor plates, tear through keratin and dermal layers, or sever tendons in Samson's legs, crippling his mobility. The claw's length and curvature also make them ideal for grappling, allowing the predator to anchor itself to Samson's body while delivering sustained attacks.
Beyond offense, the armadillo's digging adaptations give our hybrid the ability to rapidly alter terrain, creating ambush pits, undermining footing, or accessing underground cover. The bony armor from the armadillo genome adds another layer of defense, protecting vital areas from counterattacks. Combined with the predator's other genetic traits, this DNA ensures it can fight both as a siege weapon and a terrain manipulator, turning the battlefield itself into a weapon. In short, the giant armadillo's legacy transforms our hybrid into a living, breaching machine, one capable of dismantling even the most heavily fortified opponent in the hybrid war arena.
Part 12. The Gorilla. Gorilla and Gorilla berringi are the largest living primates native to the forests of central sub-Saharan Africa. Adult males, known as silverbacks, can weigh up to 180 kilograms and stand 1.7 meters tall when upright. Despite their immense size, gorillas are primarily gentle herbivores, feeding on leaves, stems, fruit, and occasionally insects. They live in cohesive family groups led by a dominant silverback, whose role is to protect, guide, and mediate within the troop. Gorillas are highly social, intelligent, and capable of complex communication through vocalizations, gestures, and facial expressions, making them both powerful and deeply sentient creatures.
Gorillas possess extraordinary muscle density and fiber composition, with a higher proportion of fast-twitch fibers than humans. This gives them explosive strength for climbing, pulling, and grappling. Their forearms, shoulders, and chest muscles are especially developed, enabling feats like bending thick branches, breaking bamboo, or lifting several times their own body weight. Estimates suggest a gorilla's strength is 4 to 9 times greater than that of an average human. This raw power is not just for combat, it's essential for daily survival in dense forests, where they must navigate vertical terrain, strip bark, and defend against predators or rival males.
A gorilla's skeleton is built for power. Their bones are denser and more robust than those of humans, especially in the arms, hands, and shoulders. The thick cortical bone provides a strong anchor for massive muscles, while the broad chest and long arm span enhance leverage for pulling and lifting. Their hand bones are adapted for knuckle walking, but also allow a crushing grip supported by exceptionally strong tendons and ligaments. This combination of dense bone and reinforced joints enables gorillas to withstand the immense forces generated during fights, climbing, or manipulating heavy objects without injury. A perfect frame for raw strength.
Gorillas demonstrate advanced cognitive abilities, including problem solving, memory, and emotional intelligence. In the wild, they use complex social strategies to maintain group harmony, resolve conflicts, and protect vulnerable members.
Captive studies have shown gorillas can learn sign language, recognize themselves in mirrors, and understand symbolic concepts. They also display empathy, grief, and even humor. This intelligence allows them to assess threats, adapt to changing environments, and make quick tactical decisions. In a combat context, such mental agility could translate into anticipating an opponent's moves, exploiting weaknesses, and coordinating attacks, traits that elevate them beyond brute force into strategic dominance. Part 13. The snow leopard, Panthera uncia, is a solitary, elusive big cat native to the rugged mountain ranges of Central and South Asia, including the Himalayas, Pamirs, and Altai. Adapted to life at altitudes up to 5,500 meters, 18,000 feet, it thrives in some of the harshest environments on Earth. Snow leopards weigh between 27 to 55 kilograms, 60 to 120 pounds, and measure up to 1.3 meters in body length, with an exceptionally long, thick tail, often nearly as long as their body, used for balance and warmth. Their dense, woolly fur, patterned with smoky gray rosettes, provides camouflage against rocky terrain and insulation against sub-zero temperatures. Wide fur-covered paws act like natural snowshoes, distributing weight and preventing sinking into snow. Snow leopards are apex predators in their range, preying on Himalayan blue sheep, ibex, marmots, and other mountain wildlife. They are ambush hunters, using stealth and terrain to get within striking distance before launching explosive attacks. Despite their power, they are listed as vulnerable by the IUCN, with fewer than 7,000 estimated in the wild, threatened by poaching, habitat loss, and declining prey populations. Their combination of stealth, strength, and agility makes them one of the most remarkable predators in the animal kingdom. Snow leopards are renowned for their extraordinary leaping ability, the greatest in the animal kingdom relative to body size. Using their long, muscular hind legs, they can leap horizontally up to 15 meters or 50 feet in a single bound, clearing ravines, cliffs, and rocky gaps with ease. This power comes from a combination of anatomical adaptations: elongated tibia and fibula bones for leverage, massive quadriceps and gluteal muscles for explosive thrust, and a flexible spine that acts like a spring to extend their reach mid-air. Their long tail serves as a counterbalance, stabilizing them during flight and landing. In vertical leaps, snow leopards can scale sheer rock faces or ascend several meters in a single jump, enabling them to ambush prey from above or escape predators in treacherous terrain. This ability is not just for hunting, it's essential for survival in their fragmented, high-altitude habitat, where cliffs and chasms are part of daily life. The snow leopard's jump is a perfect blend of biomechanics and instinct, allowing it to dominate an environment where agility is as important as strength. In hybrid war terms, this is the ultimate mobility upgrade for any predator facing a massive, ground-bound opponent. Snow leopard DNA grants our super hybrid predator unmatched vertical and horizontal mobility, enabling it to strike from angles Samson cannot defend. With leaps spanning 15 meters, the hybrid can bypass armor, reach vulnerable zones, and turn the battlefield's verticality into a lethal advantage in the hybrid war arena. Part 15. Introduction. Rare scientific name, Gigas elephantivora panthera. Common dictionary name, giant cat elephant hunter. Height, 6.5 meters, 21 feet,
at the shoulder when quadrupedal, up to 9 meters, 30 feet, when rearing bipedally. Length, 15 meters, 49 feet, from snout to tail tip. Weight, approximately 28 metric tons, balanced between elephantine bulk and predatory agility. Male, Frederick. Female counterpart, Mabel.
Its lion-based frame is reinforced with gorilla muscle density and balanced by a snow leopard's long tail. Saber fangs from Smilodon jut from its jaws, while iron-infused teeth from the short-tailed shrew ensure every bite stays razor-sharp. Its forelimbs are armed with a triple arsenal of claws: koala for grip, sloth for hooks, and armadillo for breaching. This predator is a fusion of elegance, brutality, and evolutionary perfection. The predator is a master strategist. From its lion genome, it inherits dominance and territorial aggression. Orca and African wild dog DNA grant it pack hunting instincts, allowing it to simulate multi-angle attacks even when alone. Sahel chadensis adds primal adaptability and upright grappling ability, while gorilla intelligence provides social awareness and tactical restraint. It stalks with cougar patience, ambushes with snow leopard agility, and presses attacks with relentless endurance. Unlike a mindless beast, it calculates, thinks, and adapts mid-battle. This predator doesn't just fight, it orchestrates combat, becomes a living war machine. The jaws are engineered for destruction. Powered by gorilla musculature and lion bone structure, its bite force reaches an estimated 12,500 psi, far surpassing crocodiles and rivaling prehistoric apex predators. Smilodon saber fangs deliver deep, armor-piercing strikes, while short-tailed shrew iron enamel ensures the teeth never dull. Vampire bat DNA adds a sinister twist. Anticoagulant venom in its saliva keeps wounds bleeding, weakening prey over time. This means every bite is not just a strike, but a crippling wound that worsens with each passing moment. Against a giant elephant hybrid, its jaws are the ultimate equalizer. The intellect cocktail of orca, African wild dog, gorilla, and Sahelanthropus tudensis. The predator's intelligence is formidable. Its IQ equivalent is estimated around 125, comparable to early human tool users. It can anticipate prey movements, exploit terrain, and adapt strategies mid-battle. Orca and wild dog DNA give it cooperative hunting instincts, while gorilla cognition adds problem-solving and memory. Sahelanthropus provides primal adaptability without reliance on tools, ensuring instinct-driven survival. This beast doesn't just rely on brute force. It thinks, plans, and executes with precision. In hybrid war, intelligence is as lethal as claws and fangs, and this beast has both. From its orca genome, the predator inherits a sonar-like echolocation system. It emits low-frequency pulses that map the battlefield in 3 dimensions, detecting movement, terrain, and even the heartbeat of prey through armor or walls. Combined with vampire bat heat detection, it can pinpoint vascular weak spots beneath thick hide. This sensory suite makes ambushes nearly impossible against it. The predator always knows where its enemy is, even in darkness or smoke. In hybrid war, echolocation is more than navigation. It's a targeting system, ensuring every leap, strike, and bite lands with surgical precision. The predator's hind limbs, powered by cougar and snow leopard DNA, are built for explosive leaps. It can launch itself 15 meters horizontally and 6 meters vertically, rivaling the greatest jumpers in the animal kingdom. This agility allows it to scale cliffs, ambush from above, or leap directly onto the back of a massive opponent, like Samson. Its snow leopard-inspired tail provides balance mid-air, ensuring pinpoint landings. Unlike most giants, which are bound to the ground, this predator turns vertical space into a weapon. In combat, its ability to leap transforms the battlefield into a three-dimensional arena of death.
Although a single entity, the predator's African wild dog and orca DNA grant it the instincts of a coordinated pack. It behaves as if multiple hunters are working together, feinting attacks, circling prey, and exploiting openings from different angles. This simulated pack logic overwhelms even massive opponents, forcing them to defend on multiple fronts at once. When combined with gorilla intelligence and lion dominance, it becomes a battlefield tactician, relentless, adaptive, and merciless. Against a giant elephant hybrid, this means the predator doesn't just attack head-on. It dismantles its prey piece by piece, as if hunted by an entire army.